Right, this tends to be for the higher tier students. You need to be able to do some calculations here. Foundation students, you'll need to recognise what an AC signal looks like, but you won't have to do the calculations. Right, well, basically what a CRO is, it's a voltmeter, but it's a voltmeter that shows things in a different way. It actually measures the voltage over a period of time. The way you work at the voltage is looking up the side, up the vertical axis, and the time is shown along the horizontal axis. If you notice, you've got two signals there, the X and the Y, and you can actually work out, first of all, how big the voltage was. And what you do is you measure from a midpoint, the midpoint of the line. If you notice the line going across the middle, I'm not talking about the green line, I'm talking about the grey line behind it. That is the rest point. And underneath, if you notice, underneath the whole chart, it says there T stroke div. And what that means is the time per division is 1 millisecond. And the volts per division is 2 volts. So if you look at X, for example, you can see there are 4 divisions of 4 boxes. And since each of those divisions is 2 volts, the voltage at X is 8. Okay, 2 volts times the 4 boxes it goes up is 8. And the same goes for Y. Now, the distance between X and Y is 6 boxes. If you count them along from X to Y, it's 6 boxes along, or 6 divisions. And you're told underneath that each division is worth 1 millisecond. So the time between X and Y is actually 6 milliseconds. This is a typical trace of an AC signal. AC means constantly changing or alternating current. And you can see it's sometimes got a positive voltage and a negative voltage. Anything above the line is positive, anything below the line is negative. And you can see the voltage is changing all the time. That's what AC looks like. If you examine it carefully, it is essentially the same pattern being repeated over and over again. So at C, you can see that that you've got one bit, which is in purple. If you just repeat the purple, it's the same as the red, and it's the same as the next colour after. It is the same pattern being repeated over and over again. And that complete pattern is known as a time period. Okay, so we look at C, right at the far left it goes up, then down, right to the bottom, up again, and that there's one time period. Then go to red, up, then down, then up again, another time period. And so that's one time period. And the time period there is roughly, it is in fact 4 boxes, 4 divisions. 4 divisions for the purple, 4 divisions for the red. It should be constant. You can start the time period wherever you want to. You could start at the top of the peaks here. So, and D, for example, if we start the time period at the top of the peak, you can see once again it starts at the top, goes all the way down to the bottom, then all the way to the top again, and again it's just 4 divisions across. So you can work out the time period, how long it takes for one repetition, by knowing what the time per division is. And here's a good example. The complete cycle is, again, it starts at the midpoint, it goes to the top, then goes down to the line again, goes right to the bottom, and comes back up again, almost like a giant S shape. And if you notice this time, it takes 8 boxes to go along for one time period. And now we're told that each box is worth 2 milliseconds. So 8 times 2 gives us 16 milliseconds. We're also told that the volts per division is 1 volt. So you count the number of boxes up from the midpoint. There are 4 boxes up. That's worth 4 volts. And that's the same for all of these here. Essentially what you're doing is looking at the number of time periods. In F here you've got 1, 2, 2.5 time periods, I'd say. So you measure one time period, which in this case is 4 boxes. You're told that each time per division is 5 milliseconds. 4 times 5 gives 20 milliseconds, and so forth. There's another 2 examples there you can put your heads around. Right, and the final thing that they'll ask you to do is they'll ask you to work out the frequency. And the way you work out the frequency is by, you need to know what the time period is, and we've seen as to how you can work out the time period, and you need to change that into seconds. Now, sometimes you would have been given the answer in milliseconds, and if you've been told, if you've worked out the time period in milliseconds, you need to change it into seconds, and the way you do that is you divide it by 1,000. Then you need to use that formula. Frequency is 1 over time period, or F equals 1 over T. And if you stick the value of time period in seconds there, it'll give you an answer. So there's a good example. If you looked at example E, going back a few, you would have found the time period was 16 milliseconds. And to change that into seconds, you get 16 divided by 1,000, which is 0.016. Then you use the equation, frequency equals 1 over the time period, F equals 1 over T. f equals 1 over 0.016, and that gives you a frequency of 62.5 hertz. I'll do it for the one next to us as well. If you notice for the for h, I've not written this down, but for h, if you quickly work it out, you've worked out the time period there is 12 seconds. Oh, right, this is actually going to be quite an interesting one. In this occasion, in 12 seconds, you don't need to change it into seconds because it's already in seconds. So your frequency will be 1 over 12, which is going to give an answer of 1 over 12 seconds. So it'll be something like 0.08 seconds. Hertz, sorry, 0.08 hertz will be the frequency. And if you want to go to the one G, the one before that, the answer for that is going to be something like 6 point something or other hertz is what it's going to be. It's going to be 1 divided by 0.16. Yeah, I'll tell you now, it's actually going to be 6.25 because it's very similar to the one above. So there's two examples again. But that is the higher tier question, and it tends to be the hardest question on the paper, especially if they ask you to convert from milliseconds into seconds. And that will do for that.